Hi, welcome to Code.io, and in this video of the Blind 75 series, we are going to solve this question called product of array except self. Okay, in the question you are given an array and you are supposed to find a resultant array which each of these elements in the resultant array is going to be product of all the numbers except that current element. Okay, for example, let me take this array, right? 1, 2, 3 and 4 is our array. So the expected output should be, let's say in the resultant array, if we want to populate this third index, okay, 0, 1, 2, it's the second index, okay. So the value at second index should be, you're in 3, right? You're filling the corresponding value for 3. You're going to multiply everything to the left and everything to the right, and you're going to put it here. So it's 2 into 1, which is 2, and you're multiplying that with 4, and this is going to be 8. So what we have basically done is that we are excluding this value and multiplying all other values in this array, and that will be your resultant value. Okay, now we are going to do the same for all the elements present in this array, and that is going to be your output array. Okay, so this is basically the question. Now, simple approach that you could think of is, you could multiply all the elements in this array and you have a product value, and you can divide that with each of the elements in this array, and that will give you the resultant array, right? But you're not supposed to use the division operation. That is the only catch here in this question. So because of that, we are going to use a couple of different approaches to solve this question. Okay, let me start with the easy one. It's quite easy and fairly easy to understand. So we're going to create 3 new arrays. These arrays are pre, post and the result itself. Result, it's not considered as separate memory because you're going to return that, and they want you to return a different array, right? So it's fine. So result, pre and post. So these are the 3 arrays that you're going to create. Now after this, you're going to populate these arrays one by one. We are going to start with pre-array. This pre-array is basically going to store the product of all the numbers to the left of your current element. Okay, let me explain. The first element of this array is 1, right? And there are no elements to the left of our current element, which is the first element. So the pre-array is just going to have 1, okay, because there are no other elements. The second element in our input array is 2, and there is one element to the left of 2, which is 1, okay. So you're just going to place that 1 here as well. Please follow with me, you will understand this better. Okay, the next element here is 3, and for 3 you're going to multiply all the elements to the left of 3, which is 1 and 2. So it's 1 into 2, that is 2. And we are moving with the next element, which is 4, and to the left of 4 we have 1, 2 and 3. So the product of 1, 2 and 3 gives you 6. So this is your pre-array. Okay, you have all the products of numbers to the left of your current element. Okay, for the input array you have found this pre-array. Now similarly you are going to calculate this post array. For this post array you are going to traverse from right to left, okay, because you are going to check what are the elements to the right of your current element, right? Your current element here is 4, and to the right of it there is nothing, so it's just going to be 1. Okay, the next element is 3, and to the right of 3 we have 4, so it's going to be 4. And the next element here is 2, to the right of 2 we have 3 and 4, so 3 into 4 or 3 times 4, which gives you 12. The next element that we have here is 1, and to the right of 1 we have 2, 3 and 4. 2 times 3 is 6, 6 times 4 is 24, so that gives you 24. Hi, this is me from the future. While editing, I have noticed that while explaining for population of pre and post arrays, I've mentioned how it's actually being populated, but I didn't mention how we are calculating that values. Okay, so that is what I'm going to do now. This one here, we have already placed it here. Now, while calculating this second one, what we have to do is we have to take this element from the previous value, the previous element of the same array, and are going to multiply that with your nums of the previous value, right? So what do I mean by that? Let me just write an expression here that will make you understand this pretty well. So pre of I, now in this case let us consider that we are going to populate this one, Okay, so this is going to be our ith position. Okay, so pre of I is going to be your pre of I minus 1, which is your this element. So pre of I is equal to pre of I minus 1 into nums of multiplied by nums of I minus 1. Okay, so what exactly are we doing here? This is a concept similar to our dynamic programming, right? Memoization. Not as complicated as that, but fairly simple. So you are calculating your current value by utilizing your previous value. So what is the advantage here? Now let us say you want to calculate this last value for pre. If you had to do this normally, you would be multiplying 1 into 2 into 3. Okay, so you would be multiplying 2 times and 3 numbers. Now, if let us say the array were to be 100 in size, in that case you would have multiplied 99 numbers, right? That many times you would have multiplied. That would again take order of n time, right? So for every element in this pre-array, you would take order of n time to compute the product, but that is not that efficient. In that case, it would have taken you order of n squared to populate just the pre-array. Instead of that, what you're going to do is you're going to use this previous value to compute your current value, because it's fairly simple, right? This 6 is basically this 2 into this 3. That is it, right? So that is what we are going to use here. Now the same concept is applied for populating the post array as well. We have one here, and when computing this 4, we are going to multiply this 1 with our nums of I minus 1. Okay, in case of post, it would be a bit different, because it would be pre of I plus 1 and nums of I plus 1, but the rest remains the same. So for computing 24, you wouldn't be multiplying 2 into 3 into 4, you'd just be multiplying this 12 with this 2. Okay, so that is the concept that I wanted to convey. Anyways, we are not going to use this approach to solve this problem. We have a far more elegant approach. Instead of these two arrays, we are going to use these variables. So on to the regular video now. Now these are the two arrays, pre-array and post-array, and the output result that we need is, it's just going to be product of these two numbers, the corresponding numbers in pre-array and post-array. So that's going to be 24, 12, 8 and 6, and that's it. This is going to be your answer, and you can return that straight away. Now this is a perfectly acceptable solution that you can provide, because it's an order of n solution, right? You take order of n time to populate the pre-array, you take order of n time to populate the post-array, you take order of n time to populate the resultant array. So that gives you order of n plus order of n plus order of n. That's going to be 3 order of n, order of 3n, anything is fine. So you try to eliminate the coefficient, so that comes out to be order of n. So that's your time complexity, and that is what they need as well. So this is a perfectly acceptable solution. But if in case your interviewer asks you to optimize this a bit further, in that case, what would you do? Instead of using these two arrays, you can just use a couple of variables to mimic what this array has done. Okay, and those two variables are going to be the pre and post variable. Okay, now initially we are going to have this pre and post variable as one. Let me clear up this resultant array, and what you're going to do is you're going to fill this resultant array with ones. Okay, we have created two variables, pre and post, and we have created a resultant array, and you have filled that with ones. Now this pre and post array, you can just ignore that. Those are not required for this implementation. Okay, just don't worry about that. Now what you're going to do is you're going to traverse through this resultant array twice. Once to populate the values that were present in pre-array. The second time is to traverse the same array and find the values of post and multiply with what you have already placed in the result, and that would give you the resultant array. Okay, so what do I basically mean by that? What I'm going to do is I'm going to traverse through this array for the pre product. Okay, So we are going to traverse from left to right. So that's going to be the simple approach that you're going to do is you're going to multiply your pre-value with your resultant value, and then you're going to update your pre-value. Okay, so that is what we are going to do. So how do we update your pre-value? Your pre-value will be updated as follows. Pre star is equal to nums of I, because that is what you're going to do, right? You're going to keep multiplying your all the elements to your left. This is how your pre gets updated. Now let's see how your resultant gets updated. Now for the first element here, you will be replacing, you will be multiplying your current element with pre, right? So that's 1 into 1, that becomes 1, and you're going to update this pre as well, and pre will be updated as pre into nums of I, right? In this case nums of I is 1, so pre remains the same. Now we are going to next iteration, here we come. So we are going to multiply your current element, which is 1, by pre, so that's going to be 1 into 1 again, so that remains as 1. But you're going to update pre as pre is equal to pre into nums of I. Nums of I here is 2, so that's going to be 1 into 2, so the value of pre becomes 2. Okay, I hope you got the hang of it. Now the next iteration, here we come, and it's going to be result of I is equal to result of I into pre, right? So you're going to multiply this pre with our current value, so it's 1 into 2, this becomes 2, and you're going to update the value of pre, right? You're going to multiply it with nums of I, so it's going to be 2 into 3, and that gives pre the value of 6. Moving to the next iteration at the last place here, and you're going to multiply pre with your current element, which is 1 into pre, that gives you 6 here, and you're going to multiply nums of I with pre, so it's 4 into 6, that's 24. That becomes the value of pre. Okay, now what you can observe is that this is exactly the pre-array that we previously had in our previous approach, right? It's basically the same. Instead of using an array, we have just calculated what? We have just calculated using this one single variable. Okay, so that is it. Now this is fine, but what you're going to do is, after this pre-traversal, you're going to do this post-traversal, right? This post-traversal, it's going to come from your right. Okay, from right to left is going to be your post-traversal, and I'm just going to erase this arrow. Let me draw that again here. And the approach is basically going to be the same. So you're going to take this post and you're going to multiply that post with your result of I. So that's going to be 6 into 1, which is 6. And then you will update this post by multiplying it with nums of I. So that's post becomes 1 into 4 as 4. Moving to the next iteration, you will be multiplying post with result of I. So it's 2 into 4, that gives us 8. And you will be updating post, that's going to be 4 into 3, that becomes 12, right? Moving to the next iteration, you will be multiplying post with our result, so it's 1 into 12, which is 12, and you're going to be updating post, so it's 12 into 2, that becomes 24. And for the next iteration, you're going to be multiplying post with our result, which is 1 into 24, that becomes 24, and updating post 24 into 1, that's just 24. Okay, now we have got the resultant array, and this is exactly the answer that we want. So that is the approach that is more efficient, and that is what you're going to try to code here as well. So I hope you got to know how this works and these two approaches. Now we'll move to Leetcode and try to program this in Python, but I'll also have solution for you in C++ and Java in the description, so you can go and check that out as well in the GitHub. Okay, moving over to Leetcode now. So we are here in Leetcode now, and the solution is going to be fairly straightforward. I'm just going to create a variable called n, which is going to store the length of our nums list that has been given, right? Now what I'm going to do is I'm going to create variables that I need. First, I'm going to create this pre variable, which I'm initializing as 1, and the post variable also I'm going to create and initialize it as 1. Now I'm going to create my result list, and this result list is going to be initially populated with 1, right? So result is equal to that 1 into n. So what this does is it basically creates a list populated with 1, and that is of n in size. Okay, so we have created that. Now we are just going to iterate through this nums array, and you're going to populate using pre and post variables. Okay, so for I in range of n, this is going to be pre-product, right? So result of I star equals pre, and pre is going to be updated. Pre star is equal to nums of I. As simple as that. It's basically very easy. You just have to understand that you are taking the value of pre, you are multiplying that with your result, and you are updating that pre with by multiplying it with nums of I. Okay, now you're going to do the very same thing for your post as well. I in not range of, it's going to be reversed range of. Why is it reversed? Because we are traversing from right to left. Reversed range of n, and result of I star equals post, and post is going to be multiplied with nums of I, and that basically is it, and you're going to return your result list. Let me just try to run this and see if it works properly. Fingers crossed. Okay, sample test case have passed. Let me just try and submit this. Okay, it has accepted our solution. So it's a fairly straightforward approach to solve this question in code, but I hope you got the logic as well. So see you in the next video. Thank you so much for watching. As always, I have given a link in the description where you can find Java and C++ code for the very same problem. See you in the next video. Bye for now.